Hello students, under the topic integration by parts, here we have the next problem, that is problem 14. Find the integral of x tan inverse of x dx. Now first of all we have to make the choice of u, after which the remaining we will be taking as dv, because we are going to use the formula integral u dv is equal to uv minus integral v du. So in this given question, first we have to make the choice of u. So how shall we make the choice of u? Already I have told you we have to follow this, that is ILATE. So according to this order we have to make the choice of u. Now if you see here in the question, there are two functions, one of which is algebraic and the other one is inverse function. So according to this, if we follow this rule, we see that inverse appears first. So the choice of u will be equal to the inverse function. So what is the inverse function in the given question here? It is tan inverse of x. So this will be taken as u. So tan inverse of x will be taken as u, and the remaining, so what is remaining? X dx is remaining, so that we have to take as dv. So dv is equal to x dx. Usually the students tend to forget to take this dx along with this x. If you take this dx only, you will be able to integrate it. So without fail, this dx you have to take along with this function which is remaining. So x dx will be dv. So now we have to find du and v from these two in order to substitute in this formula. So first of all, u is given to be, we have taken it as tan inverse of x. So from this, if you differentiate u with respect to x, you get du by dx to be equal to, what is the differentiation of tan inverse of x? It is 1 by 1 plus x square. Already I have given the formula of differentiation and the formulas of integrations as well in our previous lectures. If you find the playlist, you can find all those formulas over there. So from this we can write du to be equal to, taking this dx over here, we get dx divided by 1 plus x square. So this is our du that we have obtained. Now from this we have to integrate on both the sides. So when we integrate dv, we get v, and when we integrate x dx by using the formula x power n, we will be getting x squared by 2. So this will be the value of v. So now we have chosen u, from which we have obtained du, and we have also obtained v. We have to substitute all these three in the formula that I have written here. So now integral u dv. What is this? This is the given question. So this is u dv. So therefore integral the given question x tan inverse of x dx is equal to uv. What is u tan inverse of x? So we will write that. So tan inverse of x multiplied with v. What is v? V is x squared by 2. So multiply that, x squared by 2, minus integral v du. What is v? X squared by 2. And du is dx by 1 plus x square. Now let us rewrite this properly. So this, when we rewrite it, because these two are in product, let me write this term first. So x squared tan inverse of x divided by 2 minus this 2 which is here in the denominator, it can be taken out because it is a constant which is free of integration. So 1 by 2 integral x squared divided by 1 plus x square dx. So now the task here is we have to integrate this term in order to get the final answer. So what shall we do now to integrate this? So let me take this integral separately, evaluate it, and then substitute here. So what I'm going to do is I'm going to mark this whole thing as equation 1. So for because after finding this, we can say that we will take and substitute here in this equation 1. So we will evaluate this separately now. So now this one we are going to evaluate. So I have taken and written that here. And so this will be equal to, now to integrate this, we can observe that denominator has x square and the numerator also has x square. Let us make it almost same. So what is that we have to add with x square in order to achieve the denominator? In the denominator we have 1 plus x square. So we have to add 1 to this x square. So it will become integral 1 plus x square. Now because we are adding 1, in order not to change this, we have to subtract that 1 also. So minus 1 divided by 1 plus x square. So I have added this 1. Because of addition, I should also subtract that 1. So I am doing it here, and then we have the dx. Now these two terms we can consider as two different terms, and this is a denominator which is common to these two terms. So I can separate and I can write it. So I can write this as 1 plus x squared divided by 1 plus x squared dx, and then we have a negative sign here, minus this 1 divided by 1 plus x squared dx. Hope you understand this step. So if you observe carefully, you will understand it better. So remember, I am considering this as one term and this is another term. So I am separating these two terms, and the denominator is common to both the terms. So I am separating along with the denominators. So 1 plus x squared dx divided by 1 plus x squared minus 1 divided by 1 plus x squared dx. Now after this, we can cancel these two, and this we get as integral dx minus integral dx by 1 plus x square, and that will be equal to. So what is integral dx? Integral dx is x, and then minus, what is the integration of dx by 1 plus x square? It is tan inverse of x. So tan inverse of x. So this is what we obtain after integrating x squared by 1 plus x squared dx. Now let us take this and substitute in equation 1, that is in this. So we get that to be integral x tan inverse of x dx is equal to, so I have taken and written that here. So that is equal to, first this term we will write x squared by 2 tan inverse of x. So x squared by 2 tan inverse of x, and then we have minus 1 by 2. So minus 1 by 2, and then we have integral x squared by 1 plus x squared dx. So this we have evaluated separately, and we have obtained it to be x minus tan inverse of x. So let us write that. So multiplied with x minus tan inverse of x plus a constant c, which is a constant of integration. So this is the answer that we obtain for the given question. So hope you have understood this problem. Thank you.